So,
So what?
yes, sir. So in a DSC lab, so ma'am has given us to write the menu driven program. So how to write, sir, that menu driven program? So can you explain, sir?
How to?
So how to write the program, sir? Ma'am has given for the deletion. We can do the insertion, but ma'am has given means various type of problems.
Okay.
So ma'am has
Madam has not explained.
no, sir. She told that means the sir told that you have told means thoughts that why I have given so.
I taught the algorithm part.
Ah, yes, sir.
Yes. Okay. No issue. I will. So when you are free at Saturday or any other day,
Um, sir, anytime, sir. We are please.
we can discuss. Okay. Suppose
Also, can you
you
explain
have
what is
Wednesday you have class.
sir?
Friday when you have class.
DSL lab?
Friday, no, any class. You have any class on Friday.
Yes, sir.
So when you are free on Friday,
Sir,
because
after
on Friday I have class from 3 to 6.
yes,
Three
sir.
to four you have your section, then 4 to 6 others lab.
So we have also lab means 4 to 6 DSL lab.
Okay. And
So what, sir?
first half, do you have any class on first half Friday? Up to which
Uh,
time?
wait, sir. I have to see the timetable, sir.
We have 11 to 1 class, 1 to 3 o'clock it's break, and then 3 to 6
1 to
p.m.
3 break, na?
Yes.
So
Yes, on Friday.
on Friday 1 to 3. So now this Friday I don't know is possible or not, because this Friday is 12. Hmm. So we can discuss from 2 to 3, and 3 to 4 you have another hour class. So if you are ready, so we can discuss from 2 o'clock.
So most of the student means if it is 12, sir, most of the student will be means
They are
moving
in
from
transit.
yes, sir.
Okay.
They will be from means moving to the Bhubaneswar, sir.
Okay. So
So can you explain what is menu driven program, sir? I'm not
menu
able to
driven program
understand.
is nothing but like that. I am explaining. Okay. It's very easy. English program is very easy. If you know the tricks, I think now you are able to write any type of algorithm in linked list.
Yes,
Suppose is my screen visible to you?
yes, sir, it is visible.
You can see here menu driven is like that. Suppose here we create a node. Okay. This node contain two part. One is data part, another one is link part. Okay. Hello, am I audible?
Yes, sir, audible, sir.
Properly audible? Okay. So now here this is display, means it's traversal. Okay. If the root part is null, that means linked list is empty. So print the list is empty, while we can traverse each and every node and print the data of temp. Okay. Similarly, add a node at beginning, add a node at end. Okay. We can found the count of number of node in a linked list.
Yes, sir. These are the functions, no?
These are the functions. Okay. It's
Okay, sir.
very easy. And here we didn't do while loop. We menu driven means if we want to traverse, then we press 1. So if suppose here we take an int value, where uh, within int ch. Okay. So here you can see enter your choice, scan a percentage ch. If you want to traverse, then press 1. Insert a node at beginning, press 2. Insert a node at end, press 3. Count the total number of nodes, press 4. So we can press Accordingly, we call. If we press 1, then it's called display. Just to recall add function. Add at beginning means insert at the first node, before the first node. Insert in the last at end means after the last node. Okay, and length is count the total number of nodes. So if we execute this, it is very easy program. Okay, suppose
Can
enter
you
your
also share
choice.
this program?
Hello? Yes,
Can
enter
you
your
also
choice.
share this program?
Any problem?
So can you also share this program?
Yes, yes, sure. I can share this code. No issue. Okay. Suppose insert a node at the beginning, 2. So initially there is any node? Initially is there any node?
No,
Yes or
sir.
no? No. If it is there is no node, then we press 2. Okay. If we press 2, then you can see so press 2 means it's called at begin means insert at the first node. Okay. So add at beginning here. So here we create a node temp. Now enter the data into this node temp. Okay. So we create a temp or you can write y anything. Okay. We create a node y or x and insert a node in the data part of that node. And we put link null in the link part of that particular node. Now there is no node till now. Okay, there is no node till now. So here root equals to null. Yes, so this we declare a root and initialize root equals to null. Okay, so root equals to null. Yes, root equals to null. Then the list is empty and root equals to temp. There my if there is no node at all. Okay, my linked list is empty. So we create a node here and that node, that temp node is our root node or header node. You can write a header. Okay, I will modify according to that our algorithm. So it is a header. Else we know how to join at beginning. Temp का link part में we put the root root and root equals to temp. After insertion, then new node is our root. Okay. So here you can see enter your choice to
Sir, here root means header.
root means header. Okay. Accordingly, I will modify. Okay. I will no problem. Then I will send you. So enter the data of the node 10. Okay. If you insert a node 10,
Okay, sir.
then initially the list is empty and again press 1 for traversal. Again we want to enter another node to a choice to insert a node 20. Now again I enter another node to insert a node 30. Okay. Now insert another node to the node data value is 40. Now we want to traverse. So if we traverse, then we can display the element. So if we press 1, you can see first we create a node 10, then 20, then 30, then 40. Okay, so initially there is no node. So here you can see data value is 10. Then insert 20, 20 where we insert 20 at beginning. So 20, 10. Now insert 30, where we insert 30 at beginning. So 30, 20, 10. Now insert 40, where we insert 40 at beginning. 40, 30, 20, 10. Now insert at end. Suppose we enter 3. Okay, 3 means insert a node at end. Now enter the node. Suppose 5. Okay, data value is 5. So you can now again we see. You can see insert node 5. So initially it was 40, 30, 20, 10. Now insert node 5. So where we insert node 5 after this node 10. You can see insert this node 5 after this node 10. So this is called manual program. If you want to count total number of nodes, we press enter 4. So you can see 1, 2, 3, 4, 5. Total number, the length of the list is 5. That means total number of node is 5. 1, 2, 3, 4, 5. Okay. Now Suppose we press any another value, suppose 6 or suppose 5. Okay, then it will terminate. You can see invalid input, it's print invalid input and terminate the program. So this is menu driven program. Okay, I will share, no issue. It is better if I discussed personally, means in a class, then it will be more fruitful. Okay, so
Okay,
if you
sir.
can arrange any
Yes, sir. This
time,
way, if
yes.
sir, this way you can also explain some programs. So we can also do lab because in lab we face a lot of problems because we are not taught
No, if
anything
you know the
about how to write
algorithm,
it.
if you know the
Writing is
program algorithm, now you can easily write any kind of program. I believe anybody can write any kind of program if you know the algorithm. I can show you only one or two program. After that, I guaranteed you that you can write any kind of program. Okay.
okay,
So
sir.
if you have any time, specific time, then you can please tell me. Okay, so that I can arrange one classes. Okay. If you tell अगर Saturday बोलते तो Saturday I can arrange any class because Saturday you are also free and I am also free.
Sir, our reporting is there on Saturday.
Yeah, no, previous Saturday means last Saturday. Okay,
Oh,
so please, okay, please talk to each other and tell me what is the suitable time for you. Okay, then I can check is there any class or not. Then I can show you any one or two program. Then you can write any one of the any program, anything. You can see this is nothing like that. What is temp equals to temp means if instead of this, if we write y equals or if we write like this, temp equals to in algorithm we can write like this. This
yes,
is
sir.
this one is this is the one. Temp equals to temporary. How to write this one in algorithm? In algorithm we have write in like this way. Data of temp means temp arrow data. I mean data part of temp variable, I mean temp node, right? Link part of temp node and assign this value to this temp. Very easy. Okay. So one day we will discuss. Okay. You tell me, no problem. It is very easy. You can write. It's a very interesting thing. And this is very, very important when you apply for any job. Means job interview, they are generally preferred to write any algorithm, linked list algorithm for good job, means for good software company, best better software company. Okay. Now, so in the last class we have discussed about merging of a linked list. We have already discussed, right? Hello.
Yes, sir.
Okay. So today uh, we'll discuss. Okay, insert a node with data value b at the end of a node with data value q. Okay. Insert a node with data value b. Okay, at the end of a node at the end of a node with data value q. Okay. Insert a node with data value b at the end of a node with data value q. So suppose we have one linked list because your data structure syllabus is very lengthy, so programming is not possible to discuss in this class. That's why we have data programming lab. Okay. Now, suppose insert uh, suppose we have one linked list. Now insert a node whose data value is suppose 60. Okay, so that means q equals to 60. Insert a node whose data value is 60, data part is 60, after the node whose data value is 30. Okay, so insert a new node. Suppose this new node is P. Insert this new node in this linked list after the node whose data value is 30. So B value is 30, Q value is 60. Okay, question is clear to you?
Yes, sir.
Okay. Now that means we established a link between this. So this node data value is 30. We established a link between this node and this node, and then this node and this node. Okay, then this node is this node. We established a link between this node and this node, means this node link part contain the address of node P, and this node link part contain the address of this node. Okay, that means suppose it is 100, this is 200, this is 300, this is 400, and this is 500. Okay, so this, what is the header? This is my header node. Header means it is the address of the first node. So here we value 200, here the value is 300, here. So if you want to link, then suppose this node address is suppose 600. So after join, what is the address here? What is the value here?
600.
If we 600, and what is the value here?
400.
400, and this is 500. Okay, so this is my task. So if you want to insert a node with data value b at the end of a node whose data value q, what is our first task? What is our aim?
To shift the means the data value with the 40 and the 50 to the right side, sir.
First we have to search, is there any node in this given linked list? Okay, is there any node in the given linked list whose data value is b or not? Okay, first we have to search that is there any node, to find that particular node whose data value is b. Whose data value is b, we need to first we need to find that node. After find this, then only we can add. Okay, so So first we have to check, is there any node in the given linked list whose data part value is B? Okay, B may be any kind of value, any integer, character, any type of value according to your program. Okay, but before that we need to create a node P and insert the value Q in the data part of P. Okay, so first we have to create a node P. How to create a node P? What we need to write? Suppose we're going to write the algorithm.
Get
Okay,
node.
yes, we need to create a node algorithm. Suppose we're going to algorithm. Suppose name of the algorithm is insert at specific position. Okay, insert at specific position. So what are the parameter we need to first? What we know? We know the header, which is nothing but the starting address of the linked list. And what we know?
B and
Well,
Q.
B and Q. Okay, we
yes.
know B and Q. B and Q. So we know these two things: header, B and Q. Where B, we need to insert a node whose data value Q after the node whose data value is B. So first you have to create this node. Okay. So first you have to create this node P, okay, and insert 60 in the data part of node P, okay, data part of node P. So first we need to write P equals to get node. First we need to write P equals to get node. So we create a node P. Now insert value B, insert value Q. Where we insert the value Q? Data part of node B. Okay, data part of node P. So what we need to write here? Tell me.
Data P is equal to Q.
Data part of node P. Here we insert the value Q. Okay. Up to this, okay. Now we have to search this node. We have to search this particular node. We have to search this node whose data value equals to B. Okay, B equals to 30 and this node data part is 30. So we need to search this node. Now tell me how to search this node. We need to traverse to search this node. So we know the header, so we declare variable y equals to header. Okay, so first we declare y equals to header. उस नोड को ढूंढना है मुझे, तो y equals to header. Now how to check? So we need to search from the first node that this node data part equals to B or not. Okay, we need to stop at that particular position. If data part of Y equals to B or not. So when we stop, when data part of Y equals to B. Okay. So we can write while data of y not equals to b. If data of y not equals, when data of y equals to b, then we stop. Otherwise, we traverse. So what we need to write here? How to move from this node to this node? From this node to this node, how to move?
Y is equal to link of y.
Yes. So we need to write y equals to link part of y. Y equals to link part of y. So here first we create a node P. Okay. Now insert data value 60 means B a Q in this node. Now we traverse this list. Which node data part is B? Which node data part is B? We need to check. So initialize y equals to header. We declare a variable y and y equals to header. Now what is data of y? Data of y is 10. 10 equals to 60. 10 equals to b. No, 30. Sorry, 10 equals to 30. No. 10 equals to not 30. Okay, data of y is 10, not equals to 30. So now link of y. What is link of y? Link part of y 200. So 200 is my new y. Okay. So link of y is my new y. So this 200 is my new y. So this is my new y. Now check what is data of y. What is
20.
data of y? 20. 20 equals to b.
No.
Yes or no? No. Then enter into the loop. Okay. If this condition is not satisfied, then we enter into the loop. What is link of y?
300.
300. So this 300 is my new y. So this is my new y. Now what is data of y? Data of y is 30 and b value also 30. So we stop. We need to stop because data of y is 30 and b value also 30. So we need to stop. So first we have to find. So we already get this that node. So whose data value is b. Now we enter. Now we want to link between y and p. Then p here last node. Okay. So now okay. So initially, what is the value here? 400. Here 500. So before join, this is what is the value of y? 400 because this node contain the address of the next node 400 and this node contain the address of the next node 500. Now we established a link between this and this and this and this. How to establish the link? So link of y, tell me how to establish a link between y and p and this node. Now tell me.
Link of y is equal to p.
So link of y equals to p. Then so link of y equals to p means here what is the so this link will established. Now how to
Link.
establish this link? So now link of p equals to
Y.
y. Link of p equals to y. What is the value of y? What is the value of y?
So we need to store previously the link of y
First
in,
tell me what is the value of y?
so 300.
300. Y value is 300, right? So this is the link part of y. So link of y, here we put the address of p. What is the address of p? 600. So here we put 600. Then this link is established. Now we need to put here the address of this node, means 400 we need to put. Then only this link will establish. So how to establish this link?
So we will use a temporary variable, pointer variable.
Okay, without using temporary pointer variable, how it is possible? Without using temporary variable, how it is possible? Can we write here link of p equals to link of y? What is link of y?
600.
Link of y is now 600. Okay, so link of y is now 600. 600 represent this node. Okay, so this is not possible. So can we already saved, that's why it's a problem. Okay, can we write, can we establish this link first? Suppose this is y. So this node contains 400. Here it is contain 400. So 400 is the address of this node. Okay. Now this node contains 500. Can we establish this link first? Then we can establish this link. Is it possible?
Yes, sir.
Okay. So this is remain same. Now we establish a link between this node and this node. Then we establish the link between this node and this node. So if this is y, what is the link of y? What is the link of y?
400.
400. So can you say this node is nothing but link of y? Can you say this? This node also address 400 and y link part also 400. So this node is nothing but link of y. Can we say? Can we say
Yes,
that?
sir.
Now 400 we insert where? Where?
Link of
Link
P.
of p. So is it possible? This one first. Link of p equals to link of y. So we have to search that node whose data value is b. Now first we established a link between this new node and this node. Okay, so this is y link part is 400. So 400 is the nothing but the address of the next node. Now, so this is link of y. So this node is nothing but link of y. So link of y represent the next node address. The next node address is 400. So this is nothing but link of y. So this 400 we put where? At the link part of p. So that's why link of p equals to link of y. Any question? Any doubt? Up to this? This is very, very important. Any doubt?
No, sir.
No, sir.
Okay. Now this is why. So now we established. So this link already established. Now we establish this link. So this is why. So just we break this link, this one, this blue color. Okay, this blue color link. Just we break this link and we break this and add here. Okay, just to break this, इसको खोल के यहाँ लगा देते हैं. Just to break this and add here. So this is y. So what is link of this is link of y. Here we put the address of p. So p. So now we can write this one second. Link of y, here we put 600. So now this is now 600. Now we established this link. So another extra pointer is not required. Yes or no?
Yes, sir.
Okay. So that's why suppose we have one train. Okay. Now we want to insert this bogie between this and this. So you can see this is the bogie number. This is bogie number AC1. This is bogie number AC2. This is bogie number AC3. This is bogie number AC4. And we insert a new bogie, suppose AC5 between after this AC2 we want to insert this node. If we just break this link first and if we join this one, then how do we get these bogies? Because these bogies previously it was linked with the AC2, then it's complete. No? If we break this link and join with this one, then how can we get this link, these bogies? Okay,
Yes,
so
sir.
that's why first we have to link this one, then only we need to link this one. So first we have to link this one, second we have to link this one. Understood? Hello? Any question?
No, sir.
Okay. So here we need to write first. Here we can write link of P equals to link of Y. So first we need to write link of P. Okay, link of P equals to link of Y. Link of P equals to link of Y, and then link of Y equals to P. Then link of Y equals to P. Okay. Any question? So please spend 1 or 2 minute time in this. It is very, very important. Okay. So first we establish this link, then we establish this link. Okay. If we cut this link and add this link here, then this link list, okay, this link list we cannot find again. Okay. Now, next question. Write an algorithm to insert a node. Okay. Write an algorithm, insert a node into a single linked list. Okay, this type of questions may come to your exam. Maintaining the order of that list. Maintaining the order of that list. Okay. So suppose you have one node, one linked list, one, then three, then five, okay, then seven. Now we insert a node 4. Insert a node whose data value is 4 to maintain the order. So where we insert this node 4? Where we insert this node 4?
Between 3 and 5.
Between 3 and 5, so it's maintain the order. We need to insert this node here. Between 3 and 5, we need to insert this node here. You know, so first we have to establish this link, then we established this link. First we establish this link or established this link. But here there are some possibilities. What are the possibilities? Okay. Maybe first possibility is that maybe list is empty. List is empty. Then this node is our only one node and we put here null. Okay, this node P, this is only my single node, my linked list contain only one node. So header equals to P and this is my single node. What is the second possibility? Maybe you want to insert a node, suppose 0, data value is 0. Okay, data value is 0. So where you insert this node 0? At the beginning. Okay, so if data value is 0, so we insert here. Okay, so at the beginning of a linked list. At the beginning, insert this node at the beginning. Okay, suppose insert this node here. Okay, so this node is already there. So this node value is 20. This node value is 10. This linked list already there. Now we insert a node whose data value is 5. Where we insert this node? So this before the first node. Here we insert this node. Insert at beginning. Okay. What is the third one? Maybe insert a node whose data value is 8. Whose data value is 8. Where we insert this node? After the last node. So at the end. At the end. We insert this node at the end. And fourth one, as we have seen that this one. Okay, at the middle. At the middle. So these are the 4 possibilities when we insert a new node which maintaining the order of that list. First one is if the list is empty, then our new node is our header node, or we can insert a node at the beginning. Suppose in this linked list, suppose we insert whose data value is 0. So where we insert this node whose data value is 0? Here we insert this node, or so at the beginning. At the end, suppose we insert a node whose data value is 10. Where we insert this node? Here after the last node, or insert a node at middle. So this is one possibility. This is the second possibility. This is the another possibility, third, and fourth one maybe the list is empty. Is it clear to everyone? Hello?
Yes, sir.
Okay. So what is our first task? First we have to create a node P and insert a data into that node. Okay. First we have to create a node P. Okay. So algorithm insert at what is the next class? Hello?
Sir, it is the last one.
In the last class. Okay. So insert at beginning. What are the parameter we need to pass here? Insert at beginning. Sorry, insert at not beginning. Here we can need to write the order. Okay. Maybe the name of the algorithm insert at order. So what are the parameters we need to pass here? What we know? We know the existing linked list, the header, and the new node data value is B. First we have to create this node P. Okay. First we have to create this node P. So what we can write? P equals to, we can write P equals to get node. Okay. First we can write P equals to get node. Now this node data part we insert a value. Okay, this node data part we insert a value. So we can write data of P equals to B. We insert value B at the data part of P. Now first we have to check first condition. List is empty or not. How to check list is empty or not? How do you know any linked list is empty or not?
Header is equal to null.
Header null.
Header equals to null. So if header, if there is no linked list at all, if header value equals to null, if header value equals to null, then what we'll do, we can write header. So P is my new node. Okay, so P is my header because my this new node is my linked list contain only one node and that is my new node. So this is P is my header node and we put null at the link of P because there is no other linked list is there. Na? So this new node P is, and here we insert a value suppose 4. So there is no linked list exist. So this P is my header. Okay, my linked list contain only new one node which is new node and P node data part here we put null. So link of P here we put null. Okay, link of P here we put null. So this is the first one. Okay, what is the next one? If we want to insert a node at beginning. Okay, so how to check? We insert the node at the beginning. Suppose 0 we insert before 1. Okay, so how to check this node insert at beginning or not? How to check? Tell me.
Data of header is less than B.
Yes, data of header is not less than, greater than.
Yes,
Data of
sorry,
header
greater
is
than.
greater than or equal to P. Okay, suppose this is my node P. Okay, data of header is, this is the header node. So this is the header node. So data of header is greater than or equal to P, data of P, then we insert this node P at the beginning. Okay, where we insert the node at the end? So we can do two things. One, okay, data of P is greater than data of Y, or link of Y not equals to null. Okay, so please think about this third and fourth. Okay, what is the condition? Don't search from Google or anything. What is the condition? How to insert a node at the end or at the middle? So next class I will discuss this one, but please think about it. Okay, you know data part of header, if greater than or equal to data part of P, then we insert this new node P at the beginning. But how to insert the node at the end or at the middle? Okay, so please think about this.
So we need to traverse first.
First we have to need to traverse. Okay, so we can write y equals to header. Next, when we stop,
So while data of y is less than the
data of
b,
y is less than
b.
p. Data of y is less than b, or you can see data of p.
Yes, sir. Same.
Okay, data of p. So data of y, that is data of y 1. 1 less than 4? Yes. Okay. So 1 less than 4? Yes. So we insert into the node. Now we need to traverse. So what we need to write? Y
Y is
equals
equal
to
to link of y.
link of y. So if this is y, what is link of y? This one. So this one my new y. Now data of y is less than data of p. Yes, 3 less than 4. So again we need traverse. Now this is my y. Now data of y, what is data of y? 5 less than data of p. 4. No, 5 not less than 4. We need to stop. We have to stop. Okay. Now established a connection between this node and this node. How to establish a connection? Tell me.
So link of p is equal to link of y,
Link
and
of P equals to link of Y.
yes, sir.
No.
For
Y points this node, na, last node. Here, when this condition data of Y, what is data of Y? 5. 5 is less than data of P. Data of P 4. Yes, 5 is not less than 4. We stop. So here link part of P, here we put Y. Y represent this node address. So link of P, here we put Y. So now tell me how to link between this node and this node. Understood? Yes or no?
yes,
Why
yes.
represent this node? So suppose this node address is suppose 300. So here we put link part of P, here we put 300. So what is 300? 300 nothing but Y. Y represent 300. So here we put 300. Then we establish the link between this node and this node. How it is possible?
So then link of y equals to p, and then link of p equals to y can be done.
Link of Y equals to P.
Yes.
Link of y, this is y, so link of y, here why we put here the address p, यहाँ पर p का suppose address of p is 400, why we put 400 here? We put here the address of the next node, na. This is y. So link of y, this one is the link of y. Why we put here the address p? P is 400. Why put here
So,
400?
so can we
Then
do
P
this that
equals to link of Y. The reverse can be done.
Sorry?
can we do this that in the while condition we can use the data of the link of y?
Data of the link of Y.
Yes, sir.
Yes,
In
very
while
good.
condition, then sir it will
Yes,
be the same.
yes. Then it will be same. Here we know why, otherwise we need to use an extra pointer. To point, suppose we need to put another extra pointer x, and x always point the previous location. Then only we can establish the link. Because in this case, we establish this link, no problem. Link of P, we can write Y. So P का address part में 300 दे दो. What is Y? Y is nothing but the address of this node. So 300, we can easily establish this link. Okay? But how can we establish this link? How can we track this link?
Yes, sir.
If this is Y, the next node is link of Y. Because this node suppose address is suppose 600, and here the link part of Y contains 600. So link part of Y always it is indicate the address of the next node. So from this node we can traverse here, बिकॉज वाई का लिंक पार्ट में नेक्स्ट नोड का एड्रेस है, उसको देख के मैं वहां शिफ्ट कर सकता हूं. सो लिंक ऑफ वाई इज 600, so 600 is this node. But how to traverse here? Is it possible? No, because there is one direction. Is there another direction here? No, this is one direction. How can we traverse here? Back. How to traverse in back? Is it possible? No. Okay. So again, we will discuss this problem in the next class. Okay. I think most of you today are very tired. This is the interesting part of any data structure. If you once draw the diagram, you can write program means algorithm easily. And if you write algorithm easily, then you can write the program. It's very easy.
So
Very,
then
very easy.
can we use the previous address means the address of that node, sir?
Yes, we can track another way
And
also.
then give the pointer to point means pointer.
Suppose we can declare x equals to y. Okay, x equals to y. So before change, what is the meaning of this line? Link of y is my new y. So link of y indicate the previous node, and this y is my new node. Am I right or wrong? What is link part of y? Link part of y is 600. So this 600 is my new y. Then we change the y from here to here.
Yes,
Is
sir.
this clear? This line?
Yes.
Link of y. What is link of y? 600. So this 600 is my new y. So now we change this variable. This is not my y. This is my y. So before that, we can write x equals to y. Before that, we can write x equals to y. So x indicate this node or this node. X indicate this node,
Yes.
y indicate this node, and now we can establish link of x equals to p and link of p equals to y. Okay. So
Yes.
before change the value y, so initially we can write x equals to header, y equals to header. Now when we shift the value y here, x point the previous node. When y shift here, x point this node. When y shift here, x point this node. So x always point the previous node and y points the current node. हो सकता है कि नहीं हो सकता है?
Yes, sir.
Yes, sir. Yes, sir.
Okay.
Awesome.
And, but if we use extra pointer here, then and this operation also we perform this one. So time and space both are increased. Okay, because this is also one of the instruction. Okay,
Yes.
this is also one of the instruction, and it will take some time. Suppose 1 microsecond or 1 millisecond, some time it will require to execute. So time बढ़ रहा कि नहीं बढ़ रहा है? Okay,
Yes.
and also we have used this variable x, so that's why also some extra memory space is required. So as a good means programmer or if you want to write a best good algorithm, then we need to reduce this type of instruction. Using this variable x, we can write easily, but it will take some time to execute x equals to y. Okay, and also it will also allocate some space. The space complexity and time complexity both increase. So always we try without using extra variable how to write the algorithm. Okay, please think about that. Without using this variable x, how to write this algorithm? This one is
Sir,
very easy. This one not
what
a
about
problem.
that one? Data of link of y.
Yes, yes, that is correct.
Okay, sir.
Okay. Next class I will discuss this. 101,
Present, sir.
119,
Present, sir.
148,
Present, sir.
165,